So here we have, consider the series Sn is equal to -10 plus -8 plus -6 plus -4 plus and so on to n terms. 3.1, determine the general term of the series, that is Tn is equal to. So we need to figure out firstly what type of series this is. Is it arithmetic, geometric, or quadratic? If we look at it, we'll see that we do have a constant difference here. The constant difference is worked out by saying T2 minus T1. So that will be -8 minus -10, which will give me 2. And if you work out the next one, T3 minus T2, -6 minus -8 will also give me +2, which means that my constant difference is 2. So we choose the arithmetic sequence formula from the data sheet, which is Tn is equal to A plus n minus 1 into D. All you do here is you substitute your A value and your D value, open up algebraically, and simplify. So your A term is -10, your D term is +2. So you end up with Tn is equal to -10 plus n minus 1 into 2. Take that 2 into the bracket, you'll end up with Tn is equal to -10 plus 2n minus 2. Simplify, Tn will then equal to 2n minus 12, and that is your general term of the series. 3.2, write Sn in sigma notation. The first thing you do here is you write your sigma sign. On the right of the sigma sign, you need to have your formula, your general term formula, which we worked out above, which is 2n minus 12. That goes there. Now the n at the bottom, you can't start with n is equal to 0 or n is equal to 1. You just need to check which one it starts with. So you substitute, let's try n equals 0. If we substitute 0 into the general term, 2 times 0 minus 12 will be 0 minus 12, which is -12. Now my first term is not -12. So n equals 0 is not the right way to go. Let's try substituting n is equal to 1. So that will become 2 times 1 minus 12. 2 minus 12, which is -10, which is my first term. So at the bottom, my n is equal to 1. That's what I write at the bottom there. On the top of my sigma sign, the series ends to n terms. That's what the question above says. So we just write n on the top. The next one, consider the series Sn equals -10 plus -8 plus -6 plus -4 plus and so on to n terms. Show that Sn is equal to n squared minus 11n. Here they want you to work out with the sum formula for the arithmetic series. This formula you'll find from the data sheet as well. Sn is equal to n over 2 into 2a plus n minus 1 times d. All you do here is you substitute your a and your d values again. Your a value being -10 and your d value that we worked out before is 2. So substitute those two values and you'll end up with Sn is equal to n over 2 into 2 into -10 plus n minus 1 into 2. Open those brackets out, you'll end up with Sn is equal to n over 2 into -20 plus 2n minus 2, close that bracket there. Sn is equal to n over 2 into 2n minus 22. Now here in that bracket, you can pull out a common factor of 2. We should do that, so we'll end up with Sn is equal to n over 2 into 2 into n minus 11 over 1. Now the 2 from inside the bracket can cancel with the 2 there on the outside of the bracket. So we'll end up with Sn is equal to n into n minus 11. Open out that bracket by distributing and you'll end up with Sn is equal to n squared minus 11n. Okay, another sequence is given here, 3.4. Another sequence is defined as Q1 equals -12 and so on up to Q5. Write down a numerical expression for Q6. Now, as you can see, they're just adding another number at the end of each of the previous sequences there. And the pattern that I can see here is they are subtracting 2 from each of those values. So the last one there should be Q6 is equal to negative 12, minus 9, minus 11, minus 13, minus 15, and then minus 17. Okay, in the green there, I've just calculated each of those Q values as answers. We'll need to use that for the next question. So Q1 will equal to negative 12, Q2 is negative 21, Q3 is negative 32, Q4 is negative 45, and Q5 is a total of negative 60 there. 3.4.2, calculate the value of Q200 now. To calculate the value of Q200, we'll need to find the formula for this pattern. And so that can either be an arithmetic, geometric, or quadratic formula. If we look at it carefully, we'll find that our first difference there, we have first differences of negative 9, negative 11, negative 13, and negative 15. The first difference is calculated by the one after minus the one before. So T2 minus T1 will give you negative 9, then T3 minus T2 will give you negative 11, and so on. Okay, from the set of first differences, if we find our second difference, we'll find that we have a constant second difference for each of those of negative 2. As soon as we have a constant second difference, this is a quadratic formula. Now, to get the general term of a quadratic formula, the method I like to use is as follows. I circle each one of the first terms in each of those three lines there. On the top there, my formula is a plus b plus c is equal to negative 12. Then I'll have 3a minus b is equal to negative 9, and then I'll have 2a is equal to negative 2. So I get three equations, and I'll start with the bottom equation because it's the simplest. So 2a is equal to negative 2, a will equal to negative 1 then. My second equation I go with is 3a minus b is equal to negative 9, where my a, I substitute my answer of negative 1. So 3 times negative 1 minus b is equal to negative 9. And if I solve that for b, I'll end up with an answer of 6. Then my last equation, a plus b plus c, is equal to negative 12. I substitute my a value of negative 1, my b value, which I got of 6, and solve for c then. I'll end up with c is equal to negative 17. Now my a, b, and c goes in the formula of tn is equal to an squared plus bn plus c. So if I substitute into that, I'll end up with tn is equal to negative n squared plus 6n minus 17. This formula now I can use to calculate the value of Q200. So it'll be the 200th term in that sequence. So T200 will be negative into 200 squared plus 6 into 200 minus 17. And I get an answer of negative 38,817.